Section 19 of Birds and All Nature, Volume 4, Number 3, September 1898. Recorded for LibriVox.org by Rosehip. Eyes by W. E. Watt. Why was the sight to such a tender ball as the eye confined, so obvious and so easy to be quenched, and not as feeling through all parts diffused, that she might look at will through every pore? Milton. But being only eyes, you see, my vision's limited. Sam Weller. The reason we know anything at all is that various forms of vibration are capable of affecting our organs of sense. These agitate the brain, the mind perceives, and from perception arise the higher forms of thought. Perhaps the most important of the senses is sight. It ranges in power from the mere ability to perceive the difference between light and darkness up to a marvelous means of knowing the nature of objects of various forms and sizes at both near and remote range. One of the simplest forms of eyes is found in the sea anemone. It has a colored mass of pigment cells and refractive bodies that break up the light which falls upon them, and it is able to know day and night. An examination of this simple organ leads one to think the scientist not far wrong who claimed that the eye is a development from what was once merely a particular sore spot that was sensitive to the action of light. The protophyte, Euglena viridis, has what seems to be the least complicated of all sense organs in the transparent spot in the front of its body. We know that rays of light have power to alter the color of certain substances. The retina of the eye is changed in color by exposure to continued rays of light. Frogs, in whose eyes the color of the retina has apparently been all changed by sunshine, are still able to take a fly accurately and to recognize certain colors. Whether the changes produced by light upon the retina are all chemical, or all physical, or partly both, remains open to discussion. An interesting experiment was performed by Professor Tyndall, proving that heat rays do not affect the eye optically. He was operating along the line of testing the power of the eye to transmit to the sensorium the presence of certain forms of radiant energy. It is well known that certain waves are unnoticed by the eye, but are registered distinctly by the photographic plate, and he first showed beyond doubt that heat waves as such have no effect upon the retina. By separating the light and heat rays from an electric lantern and focusing the latter, he brought their combined energy to play where his own eye could be placed directly in contact with them, first protecting the exterior of his eye from the heat rays. There was no sensation whatever as a result, but when, directly afterward, he placed a sheet of platinum at the convergence of the dark rays, it quickly became red hot with the energy which his eye was unable to recognize. The eye is a camera obscura with a very imperfect lens and a receiving plate irregularly sensitized, but it has marvelous powers of quick adjustment. The habits of the animal determine the character of the eye. Birds of rapid flight, and those which scan the earth minutely from lofty courses, are able to adjust their vision quickly to long and short range. The eye of the owl is subject to his will as he swings noiselessly down upon the mouse in the grass. The nearer the object, the more the eye is protruded, and the deeper its form from front to rear. The human eye adjusts its power well for small objects within a few inches, and readily reaches out for those several miles away. A curious feature is that we are able to adjust the eye for something at long range in less time than for something close at hand. If we are reading and someone calls our attention to an object on the distant hillside, the eye adjusts itself to the distance in less than a second, but when we return our vision to the printed page, several seconds are consumed in the readjustment. The condor of the Andes has great powers of sight. He wheels in beautiful curves, high in the air, scrutinizing the ground most carefully, and all the time apparently keeping track of all the other condors within a range of several miles. No sooner does one of his kind descend to the earth than those near him shoot for the same spot, hoping the find may be large enough for a dinner party. Others soaring at greater distances note their departure and follow in great numbers, so that when the carcass discovered by one condor proves to be a large one, hundreds of these huge birds congregate to enjoy the feast. The condor's eyes have been well compared to opera glasses, their extension and contraction are so great. The eagle soars towards the sun with fixed gaze and apparent fullness of enjoyment. This would ruin his sight were it not for the fact that he and all other birds are provided with an extra inner eyelid called the nictitating membrane, which may be drawn at will over the eye to protect it from too strong a light. Cuvier made the discovery that the eye of the eagle, which had up to his time been supposed of peculiarly great strength to enable it to feast upon the sun's rays, is closed during its great flights, just as the eye of the barnyard fowl is occasionally rested by the use of this delicate semi-transparent membrane. Several of the mammals, among them being the horse, are equipped with such an inner eyelid. One of my most striking experiences on the ocean was had when I pulled in my first flounder and found both of his eyes on the same side of his head. All flatfish are similarly equipped. On the side which glides over the bottom of the sea, the halibut, turbot, plaice, and sole are almost white, the upper side being dark enough to be scarcely distinguishable from the ground. On the upper side are the two eyes, while the lower side is blind. When first born, the fish swims upright with a slight tendency to favor one side. Its eyes are on opposite sides of the head, as in most vertebrates, and the head itself is regular. With age and experience in exploring the bottom on one side, the under eye refuses to remain away from the light and gradually turns upward, bringing with it the bones of the skull to such an extent that the adult flatfish becomes the apparently deformed creature that appears in our markets as a regular product of the deep. The eyeless inhabitant of the streams in Mammoth Cave presents a curious instance of the total loss of a sense which remains unused. These little fishes are not only without sight, but are also almost destitute of color and markings, the general appearance being much like that of a fish with the skin taken off for the frying pan. The eyes of fishes generally are so nearly round that they may be used with good effect as simple microscopes and have considerable magnifying power. Being continually washed with the element in which they move, they have no need for winking, and the lacrimal duct, which supplies tears to the eyes of most of the animal kingdom, is entirely wanting. Whales have no tear glands in their eyes, and the whole order of Cetacea are tearless. Among domestic animals, There is considerable variety of structure in the eye. The pupil is usually round, but in the small cats it is long vertically, and in the sheep, in fact, in all the cud chewers and many other grass eaters, the pupil is long horizontally. Insects present a wonderful array of eyes. These are not movable, but the evident purpose is that there shall be an eye in readiness in whatever direction the insect may have business. The common ant has 50 six-cornered jewels set advantageously in his little head, and so arranged as to take in everything that pertains to the pleasure of the industrious little creature. As the ant does not move about with great rapidity, he is less in need of many eyes than the house fly, which calls into play 4,000 brilliant facets, while the butterfly is supplied with about 17,000. The most remarkable of all is the blundering beetle, which bangs his head against the wall with 25,000 eyes wide open. End of section 19. This recording is in the public domain.